Right, so let's try this next problem here. So basically you have an equation and right, so you have an equation and the first part is what are the two values of x that cannot be solutions to this equation no matter what the value of k. Alright, so when they say this expression, what values of x that cannot be solutions, you really are just looking for the value of x that will never work, and it will not work. X will not work. It will not work when your denominator is equal to 0. Okay, so you need to find a value of x that will make the denominator 0, and you cannot have that x value for as part of the solution. Right, so you have two fractions in here. This first fraction, you have x minus 1 over x minus 2. Your denominator is x minus 2. So what value of x will make the whole denominator equal to 0? This whole thing equal to 0 when your x is equal to 2. So when you have 2 in here, 2 minus 2 equals 0. That will not work. So therefore, you cannot have x equals 2. Alright, and then on the second part of your fraction, x minus k over x minus 6. Okay, so therefore in here, the x that will make this 0 is 6. So therefore you cannot have a value of 6. So really the idea, every time you have a fraction that has an x in your denominator, set that one into 0, and whatever the value of x, that's the answer. That will never work. Okay, alright, that will never work. Okay, letter B. Let me clear this sheet first. Alright, letter B. Get rid of fractions by multiplying both sides by appropriate binomial. Solve the resulting equation for x. So we want to solve for x, and this is your fractions right here. Okay, so this is just like ratio and proportion. Quick example. Say for example you have 2 over x is equal to 5 over, I don't know, 6. Right? So now we cross multiply this and that. Denominator times numerator, 5x is equal to denominator times numerator, which is 12. And then you solve for x. We solve for x by dividing this by 5. So therefore your x is whatever the answer here, which is 2.4. Okay? So that's basically what we're going to do. Only that you have binomials. Okay, so let's copy your fraction. This is letter B. Okay, x minus 1 over x minus 2 is equal to x minus k over x minus 6. Okay, so denominator times numerator, so you would have x minus 6 times x minus 1 is equal to this denominator times that numerator. So you would have x minus 2 times x minus k. Alright, so we will multiply this binomial right here. When we multiply each of the term to each and every term at the same side of the equal sign. So this x here, you multiply to your x. Okay, so that becomes x squared. And this same x, you multiply to negative 1. And so that will give you minus 1x. And this negative 6, you're done with the x. Now you multiply negative 6, negative 6x. And then negative 6 times negative 1, you have plus 6. Okay, that is that one side there. Now let's do the other side. Multiply x times x, you have x squared. X times negative k, you have minus x k or kx. You should have written that as kx. Alright, that's kx. Oops. Alright, just take note, that's kx. And then now you're done with x, you do negative 2. Negative 2 times x, you have negative 2x. And then negative 2 times negative k, you have positive 2k. And so let's simplify this side here. We combine like terms, right? So you have, let me write here on top, you have x squared. So you have negative 1 minus 6, they're all both x's. You have minus 7x, okay? Plus 6. Right, so you're done on the left side of the equal sign. Copy the equal sign and simplify the other one. So you have x squared. So you can see this one here is negative x or negative kx. minus 2x. They both have x's, right? So we can factor out the x. And okay, so you can actually, let's keep it that way for now. It's probably simpler. Plus 2k. All right, so now if you look carefully, this equal sign right here, you have these three terms, and on the other side you have four terms. But both sides have x squared, so really you can just subtract this because they're the same anyway, so as good as it's gone. Okay. All right, so now let's look carefully here. You have a constant, meaning just a plain 6, and this is considered a constant because it doesn't have an x. So therefore, this constant must be equal to that constant because they're both constants. That's the first thing we will solve. Actually, no, let's not do that. The situation here says you solve for x. You need to solve for x. So therefore, we kind of need to combine all the x's here. All right, so let me see first. Okay, so let's combine all your x's. You have negative 7x here. Let me rewrite that. Negative 7x plus 6 is equal to negative kx minus 2x plus 2k. Okay, see this x right here? We want to put that in here. So we add 2x here. You add 2x. So this one becomes negative. I'm doing it step by step. Negative 5x plus 6 is equal to, this is gone now, negative kx plus 2k. All right. Now you still have an x in here. You want to put the x on both same side of the equal sign. So this positive kx, you can subtract, or you can add kx there, and you also add kx here. Okay, of course this one will cancel out. This one you cannot really combine because 5 and k. So you can just write negative 5x plus kx plus 6 is equal to 2k. Now 2k doesn't really have an x, so you can just get rid of that 6 by subtracting it and minus here. So now you would have negative 5x plus k is equal to, this one will zero out, is equal to 2k minus 6. Okay. Now let me get a clean sheet of space here. Um, all right, so let's continue this equation right here. Oh no, this will not work. Actually, this will not work. I'm sorry, this is supposed to be negative 5x plus kx. Okay. Oops, it's not gonna write. Plus kx. All right, and we will copy this. I hope I don't forget. Negative 5x plus, well, let's factor out your x. You can factor out your x and you would have negative 5 plus k. X is equal to negative 2k minus 6. Oh, that's positive 2k. 2k minus 6. All right. I hope I remember that number. Okay, so you have negative 5 plus k. X is equal to 2k. Was it plus 6? Let's see. 2k minus 6. Our latest was negative 5 plus k. X is equal to 2k minus 6, and we want to solve for x. So this x you need to divide. This is the whole parenthesis represents one number, so you need to do, you can rewrite this one as well as negative 5 plus k, and you also have to divide this by negative 5 plus k. All right, and this will cancel out. Okay, so let me write it here. X is equal to 2k minus 6 over, remember negative 5 plus k can be written out as k minus 5. Alright, so this is your answer for letter B, if you want to solve for your x. I know it looks long, but I mean, with practice, I'm pretty sure you can find this. Alright, part C. Part C says, for what values of k is there no solution to equation B? What values of k? Now remember, you will not have a value of k, you will not have a solution for k if your denominator is equal to 0. So therefore, your k cannot, this is letter C, your k cannot be equal to 5. Because if this is 5, 5 minus 5 becomes 0. Right? Part D. Does part A also produce a value of k for which there is no solution to the original equation? Now, let's try to remember that. 2k minus 6. Right, so we know that your x is equal to 2k minus, what was that problem number? Well, my memory is not so good. 2k minus 6. Okay. 2k minus 6 over uh, k minus 5. Right. Now from letter A, we know that x cannot be equal to 2 and also x cannot be equal to 6. So really we just substitute this in here. Okay, so for the first one, when we say when your x is equal to 2, then that's going to be 2k minus 6 over k minus 5. All right. Oh, this is supposed to be 2. So this is part A of D. Alright, so 2 is like a whole number that's over 1. Then you can cross multiply again. So you can say 2 times this, k minus 5, is equal to 1 times that. So that's basically 2k minus 6. We distribute this, so you have 2k minus 10 is equal to 2k minus 6. When you subtract 2k and 2k, you have negative 10 equals negative 6, which is not true. Not true. Okay, so therefore you really don't have, this one doesn't really work. It just shows that it doesn't work. Now if we try 6, we do this again, but we try 6. So we say 6 is equal to 2k minus 6 over k minus 5. This is a whole number, just put over 1, cross multiply, so you have 6 times denominator here, k minus 5 is equal to 1 times numerator here, 2k minus 6, and we distribute this. You have 6k, 6 times 5, negative 5 is 30, is equal to 2k minus 6, right? Combining like terms, you add 30 here, add 30, right? So you have 6k, 6k, this one will cancel out, is equal to 2k minus or plus 24, okay? You want to combine all the k's, you subtract 2k here, subtract 2k. Therefore, 4k is equal to 24. So therefore, from here, you know that k is equal to 6. 24 divided by 4, right? So therefore, the values of, so this one here, meaning, remember, when your x is 6, it will not work. So therefore, when your k is 6, your x will be wrong, okay? Your x cannot work. So therefore, we have this answer and the other one, this one right here, k equals negative, k equals 5. K cannot be equal to 5 from letter C, and from letter D, K cannot be equal to 6, right?